Good morning, everyone. This is Wednesday, April 29th. This is lesson 10. You will have a review tomorrow for your end of mod assessment, and that will be on Friday, May 1st. Okay, let's get started. Okay, our target for today, I can solve real-world problems involving area of figures with fractional side lengths using visual models and or equations. Okay, so make sure, again, you should be familiar with the two methods that we've been talking about, the break-apart distribution property and the changing of the mixed number into an improper fraction. Okay, so we're going to use real-world problems, and we are going to use our visuals, which means you can sketch and draw it, or you can make equations. So make sure you have your materials ready, a pencil in your notebook or some paper, and the vocabulary, your visual models, just means to make a sketch of your figures, labeling each of the sides that you could see and then solve. Your fluency for today, I'd like you to sit on the floor and touch your toes and then reach up to the sky when reciting your multiples of 6. So I'm going to give you a second to get off of your seat or your chair, your couch, or your bed and sit on the floor or sit on your bed, whichever you choose. Okay, and touch your toes and reach your hands up to the sky. When you touch your toes, you will say, or when you reach to the sky, you could say a multiple, whichever one. Ready? Begin. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. And as you can see by now that knowing your multiples is an extremely good thing to know, because when we're changing mixed numbers to improper fractions and the reverse, we're always using multiplication, especially with these fractional models. Okay. So let's start off today by reviewing multiplication of mixed numbers. We've been doing this in our past lessons, and this will definitely assist us with our lesson today. So here we go. Go ahead and try on your own, and then I will give you the answer as we go along. 1 1/4 times 4 1/3. What do you think 1 1/4 should turn into and 4 1/3 should turn into? I'm giving you a little time to think about this. You have 2 questions there. Okay, 1 1/4 should be 5 over 4, and 4 over 3 should turn into 13 over 3. Okay, so now you have 5 times 13, which is 65, and 4 times 3, which is 12. And that is an improper fraction. You need to take your top number, put it in the house. Your 12 goes on the outside of the house, divide it, and you will get 5 and 5 over 12. Okay. How about that bottom one? 2 1/5 turns into 11 over 5. And 3 7/8 turns into 24 plus 7, which is 31 over 8. Now I have 11 times 31. Multiply across, multiply across. So we're going to say 11 times 31 and 5 times 8. And we get 341 over 40. And when you divide that, 341 goes inside the house, 40 goes on the outside, and you divide and you get 8 and 21/40. Okay. A little review before we start. So, to begin our lesson, I'll complete this problem as you follow along with me. So read aloud as I read this to you. The length of a flower bed is 4 times as long as its width. Okay, so now that sounds like it to me. That sounds like to me we're writing an expression, and we learned how to do that in our last module. So the length of a flower bed is 4 times as long as its width. If the width is 3/8 meter, what's the area? So we have to write an expression first. 4 times as long as its width, and the width is 3/8. So let's write that. So I'm going to say 4 times 3/8. Okay. So here's my width. Here's a little picture here. And if you notice, I'm using a tape diagram. No crisscrosses, just like a little piece of tape that we're breaking up into parts. Your width is 3/8. Here's your length. 4 pieces. 1, 2, 3, 4. It said 4 times as long. Each one is worth how much? 3/8. Okay? And they did say meters. So when we go to label, we have to make sure that we label with an M. Okay, so the length, 3/8 times 4 is 12/8, which gives me 3/2. Three over 8 times 3/2 equals 9/16. 9/16 meters squared. Okay, let's move along. Okay, here's another one to try. Watch as I do this one and follow along. Look at this as I talk you through this. Remember, if you have a square, all the sides are equal. Only one side is labeled, and we know that the formula for area equals length times width. So if you labeled your length and your width, you would have 5/8 as a length and 5/8 as a width. So 5 times 5 is 25, and 8 times 8 is 64. And you would have 25/64 square yards. Let's do this together. We will be solving part A and B. Please listen carefully and follow along. Janet bought 5 yards of fabric 2.5 feet wide to make curtains. She used 1/3 of the fabric to make a long set of curtains and the rest to make 4 short sets. Find the area of the fabric she used for the long set of curtains for A, and B, you're going to find the area of the fabric she used for the short sets. So let's make a tape diagram. That's the first thing we're going to do. So Janet bought 5 yards of fabric 2.5 feet wide to make curtains. I made 5 parts. 1, 2, 3, 4, 5. She used 1/3 of the fabric to make a long set of the curtains. So she divided that up. 5 divided by 1/3 would be 5 yards. So 5 feet. So here we go. 1/3 of 15 is 5 feet. Okay. That shows you right here. 1/3 of 15 is 5 feet. Okay. So area equals length times width. 5 times 2 1/4 to make curtains. She needs 5 times 2 and 1/4. So 5 times 2 and 1/4 is 8 plus 1 is 9 over 4, which equals 45 over 4. When we divide that out, we get 11 and 1/4 feet squared. Remember, when they ask you a question, then you have to come and restate the question and put your answer in there, labeled. The area of the long set of curtains is 11 and 1/4 feet squared. Now let's complete part B. Janet bought 5 yards of, I just put the same question up there so you would have it again on this slide. So we're going to do B, find the area for 4 short sets. Okay, so keeping in mind that we used 5 feet, so we subtracted 15 feet minus 5 feet, got 10 feet. So 1/4, because there's 4 sets, 1/4, 2/4, 3/4, 4/4, okay, the short sets. 1/4 of the 10 yards, we have 10 over 4, which equals 2 over 2 and 2/4, which equals 2 1/2. So look at this here, 2 1/2 times 2 and 1/4 is 5 over 2 times 9 over 4, which gives us 45 over 8. And when you divide that out, you get 5 and 5/8 feet squared. You have to divide that. Okay. Now I'm going to give you a problem to solve. I will pause, or you will pause the video, and then we will go over it again. So find the area for all 3 of these rectangles. So here's this one here, and this one here. Okay, go ahead. Some wire is used to make 3 rectangles, A, B, and C. Rectangle B's dimensions are 3/4 centimeters larger than rectangle A, and C's dimensions are 3/5 centimeter larger than B's. Rectangle is 2 centimeters by 3 1/5. So here they drew what I just read. Each one is drawn and labeled. Okay, so let's put in that this is A. Okay, solve those. Pause this and solve those, please, and come back. Okay, so let's solve this together. The first one, A, 3 1/5 times 2. Again, boys and girls, this is going back over changing mixed numbers into improper fractions. 3 1/5 would be 16 over 5 times 2. You would get 32 over 5, and then you would divide that out and get 6 2/5. Okay. The next part. 3 4/5 times 2 3/5. 3 times 5 is 15, plus 4 is 19 over 5, and 2 times 5 is 10, plus 3 is 13 over 5, which is going to, now you're going to multiply your numerators. Multiply across, 19 times 13, you get 247, and 5 times 5 is 25. And when you divide that, right here, you have to divide 25 into 247, 247 going in the house. You are going to get 9 and 22 over 25. And our last one is rectangle C, 4 2/5 times 3 1/5 is going to equal 22 over 5 times 16 over 5. So 20 plus 2 is 22, and 5 times 3 is 15, plus 1 is 16, and you put them over the denominators given. And you multiply them together, you get 352 over 25. And when you divide them, 352 going in the house to divide, you get 14 and 2 over 25. When you add up all your areas, what do you get? Remember, you have to use all the same denominators. So we had to make 6 2/5 we had to get the denominator of 25. So we turned 6 and 2/5 into 6 and 10 over 25, plus 9 and 22 over 25, plus 14 and 2 over 25, which is going to give you, bingo, 30 and 9 over 25. Okay. If you wanted to show another strategy for that problem, it would look like this. You can break it apart using the distributive property if that's a better way for you. Each of these rectangles are split up 3 and 1/5 times 2. 3 times 2 is 6. 1/5 times 2 is 2/5. And there you got the same answer that we got when we used the mixed fraction to improper fraction strategy. Then you have 2 over 3. 2 times 3 is 6. 2 times 4/5 is 1 and 3/5. 3 times 3/5 is 1 and 4/5. And 4/5 times 3/5 is 12 over 25. And when you add those together, you get what we got for B. And C, same thing. 4 times 3 is 12. 2/5 times 3 is 1 and 1/5. 4 times 1/5 is 4/5. And 2/5 times 1/5 is 2/25. And then you get 2 over 25, I should say. And then when you added them together, you got 14 and 2/25. When we added these, just like we did in the last example, you had to get this common denominator, which was 25. So we changed 6 and 2/5 to 6 and 10 over 25. When we added them all together, the area was, or is, 39 over 25. And let's label that. And what should it say? It should say centimeters squared. Okay. Okay, so boys and girls, don't forget, these are some really good examples that we've been going through in each lesson. If you have any questions, go back and look first and see if you can figure it out. If you can, then you can always get a hold of me and I can help you. So let's review our target. I can solve real-world problems involving area of figures with fractional side lengths using visual models and/or equations. Remember, everything that we did in today's lesson is a combination of what we've been learning in our past lessons. So when completing your homework, just take your time, go back and look at the slides here today to help you solve. Don't get frustrated, just try your best. I know you can do this. You got this. Okay, miss all of you and have a great night.